Probability homework 3, video key. So this is problem number 1. So again, this is unconditional probability. A bucket contains 50 lottery balls numbered 1 to 50. One is drawn at random. The way we interpret this is find the probability of picking a multiple of 6 given that it's a 2-digit number. So we know it's a 2-digit number. So we can eliminate balls numbered 1 through 9. So that means even though you think, oh, 2-digit number, 10 to 50, some people might think, oh, that's 40 balls. It's actually 41. It's actually 41. There's only 9 single-digit numbers. 10 to 50 is 41. So we know there are 41 balls, 41 2-digits, 2-digit balls. And we want to find the probability of getting a multiple of 6. Well, multiples of 6 that are 2 digits, we've got 12, 18, 24, 30, 36, 42, and 48. That's 1, 2, 3, 4, 5, 6, 7. So 7 out of 41 would be your final answer there. 7 out of 41. Okay, Marty rolls 2 dice. What is the probability that the sum of the dice is 7, given that the first die is showing a 2? Okay, so again, it says we roll 2 dice. That is true, but we only really need to look at the probability of the 1 die, because we know the first one's a 2, and then we have a second one, that's a question mark, and we want their sum, 2 plus blank, to equal 7. Well, what are the chances of it being 7? Well, we know there's only one number that can go here to make it 7. That's 5. So it must be 5. We must roll a 5 to get a 7. And what are the chances of rolling a 5? Well, it's a normal 6-sided die, so that would be a 1/6 chance. 1/6 chance of the sum being 7, given that the first die is showing a 2. All right, number 3. The month of the year is randomly chosen. Find the probability that it has no more than 30 days, given that it starts with the letter A. So the month of the year is randomly chosen. Find the probability that it has no more than 30 days, given that it starts with the letter A. Okay, so we got a bunch of months of the year. Let's talk about the months of the year. So we've got January, February, March, April, May, June, July, August, September, October, November, and December. So those are our days of the year. Those are our months of the year, excuse me. So got our months of the year. We know what we've already selected is that it starts with the letter A. So we have 2 that start with the letter A. April and August. Okay, we want the probability that it has no more than 30 days. So we want the probability that it has 30 days or fewer. Well, the little saying, 30 days has September. So the ones with 30 days are September. 30 days have September, April, June, and November. These are our 30-day ones. Everything else has 31 except for February, which has 28. But again, of the 2, what are the chances? So this one has 30, and this one in August has 31. So given that it starts with an A, what are the chances that it has no more than 30 days? That would be 1 out of 2. Because only one of the 2 has no more than 30 days. So 1/2. Okay, out of 125 children at a summer camp, 45 signed up for swimming and 38 signed up for arts and crafts. 12 students who signed up for swimming also signed up for arts and crafts. So we have our Venn diagram problem. So this is our problem that has overlapping categories. And whenever you have overlapping categories, it's always a good idea to express it as to organize your information with a Venn diagram. So 2 circles. Have one for swimming, and another for arts and crafts. AC for arts and crafts. And then we have a larger one to represent all of the students total, all the 125 students at the summer camp. So using algebra, we can actually make this kind of simple. So here's the basic idea. We know there are 125 children total at the camp. So the sum of all of these individuals has to be 125. And then it says 45 signed up for swimming. So together, A plus B has to be 45. So A plus B equals 45. I also know that 38 signed up for arts and crafts. That's B plus C. So B plus C equals 38. And then it says 12 students signed up for swimming, also signed up for arts and crafts. So that tells us that B is 12. So we know B is 12. So I can start filling these in. That's 12 right there. So that's 12. We know A plus 12 equals 45. So I can subtract 12 and get that A is 33. So this must be 33. And then I also know that B is still 12. So 12 plus C equals 38. Subtract 12 and I get C equals 26. And then I can use those all three, to figure out what no one signed up for. And again, notice I haven't even determined what the question's even asking. I'm just organizing my information to figure out what students did what at the summer camp. So I know that 33 plus 12 plus 26 plus D equals 125. And subtract all those over. So that 59, 71, 125 minus 71 equals D, which is 54 students. So 54 students right here. And there we go. So that's how we can determine, and remember D represents people that didn't do swimming or arts and crafts. So now we can answer the question. Now we can look at the question and see if we can answer it. What is the probability that a student is signed up for swimming if it's known that they did not sign up for arts and crafts? Okay, so what are the chances of signing up for swimming if they did not sign up for arts and crafts? So we know of the students that did not sign up for arts and crafts, that's anyone outside of this AC circle, so not B and not C. So these are our not arts and crafts. 33 plus 54. So that's 87 total students, or 87 total children at the summer camp. And then finally, what's the chance that they signed up for swimming? Well, out of these two, which one signed up for swimming? Just the A's. So it's 33 out of 87. And that is our final answer. Now it does reduce. You could put it in the calculator and find that out. And it reduces to 11 over 29. 11 out of 29. All right, number 5. Again, this is another example, just like the previous one. Out of the 56 players on the football team, 24 on honor roll and 18 have perfect attendance. Again, this doesn't mean that all 56 players on the football team have to be categorized. Okay, so there's the football team, and then we have H for honor roll, and we have 18 P for perfect attendance. So we can call them A, B, C, and D if we want to again. And we know that 56 players total, so all of the letters add up to 56. It says 24 are honor roll. So the honor roll students, that's A and B, because the ones that count as both, B represents perfect attendance and honor roll. So A plus B is honor roll, that's 24. B plus C, that's perfect attendance, that's 18. Just looking at this. And it says 7 are both honor roll and perfect attendance. That tells us B is 7. So we can start plugging things in. B is 7. So I know this B is not B, it's now 7. That's 7 plus C equals 18. I can use that to get C equals 11. So C equals 11. And I know that A plus 7 equals 24. You can subtract 7, get A is 17. And then I can know that there are 56 football players total. These three add to 35. I do 56 minus 35 to get 21 players are neither on the honor roll nor have perfect attendance. All right, now we can answer the question. Okay, if a player is chosen at random, what is the probability that they are on honor roll if it's known they also have perfect attendance? So, of the perfect attending students, what are the chances that they're on honor roll? So, the perfect attendance students are the ones inside of the P circle. That's 18 total, 7 plus 11. So total, it's out of 18. And what are the chances that they're on honor roll? Well, of these 18, which ones are on honor roll? Just those 7. So it'd be 7 out of 18. Okay, moving right along. Table below shows the number of students that do or do not have their own cars and whether they have part-time jobs. Okay, so again, this is a two-way table. So we want the probability of a student with a part-time job without a car. So with a part-time job, but without a car. Now notice, this is not conditional probability. There's no condition here. Okay, so it's just out of all the students, we want the probability that we pick one that has a part-time job but doesn't have a car. So has a part-time job, so we want this one, yes, but no part-time car. So that'd be 30. So it'd be 30 out of the total number of students. All we have to do to find the total number of students is add them all up. So 78 plus 30, that is 108. 18 plus 24 is 42. Add those two up, we get 150 total students. So we know there are 150 students overall. So it's 30 out of 150, which simplifies to 1/5. All right, what are the chances, or what's the probability of picking a student that has no car? So remember, this means probability so this means probability of picking a no car student, picking no car, given no part-time job. That's what that notation means. That's how we interpret that. So given that they have no part-time job, so all we care about is just the students that have no part-time job, because we already know it's only those. So out of those, what's the chances of picking a no car? Well, we've got 24 no cars and 18 yes cars. So it'd be 24 out of whatever this total is, which we already totaled at 42, which we can reduce to 12 out of 21. Actually, we can divide both by 3 and get 8 out of 14. Actually, we can divide both by 6. So instead, it'd be 4 out of 7. 4/7. Okay, again, this next one, how we interpret this, we want the probability of picking part-time job. So yes for part-time job, given that they have a car. So that's what that notation means. So of the people that have a car, so we're only looking at the students that have a car. So of the students that have the car, so which ones have the car? Just these two. So of the students that have the car, what are the chances of picking yes for part-time job? So it would be 78 yes, 78 out of the ones that have a car, 78 plus 18, it's 96. 78 out of 96. And ends up being 39 out of 48. And I'll show you how to do that on the calculator, actually. So on the calculator, we can do 78 out of 96. And hit math, enter, enter. So math frac. 13 out of 16. 13 out of 16. Both divisible by 6. All right, last problem. And again, the joint relative and marginal relative frequencies, I'm not terribly concerned with these. So I just want you to be able to come up with the probabilities from this table. Okay, so probability of not attending grad school, just overall, based on this. So remember, this means greater than 3.0 GPA. That means less than. So what's the general probability of not attending grad school? Well, who's not attending grad school? All of those students. 18 plus 54 is 72. We can say 18 plus 54. That's 72 out of the total number of students. Well, there are 72 that aren't going to grad school. If we add those up, we get 128. Add those two together, and we get that there are 200 total students. So it'd be 72 out of 200, which simplifies to 72 out of 200. Math frac. 9 out of 25. Okay. Again, another non-conditional probability. It's both. It's 2. These two on the bottom are conditional probability. So probability of selecting a 3.0 of getting less than 3.0 GPA. So this one, and not attending grad school. So for this one, we're only looking at where they have less than a 3.0 GPA and they're not attending grad school. That's just this 54. And since there's no condition, it's out of the total. It's 54 out of 200. So it'd be 27 out of 100. Hope that simplifies too. Okay. Second to last one, we have part C. We have the probability of not attending grad school. Probability of not attending grad school given that they have greater than a 3.0 GPA. So again, we're only looking at the students that have greater than a 3.0 GPA. So I'm going to erase some of this actually, just so we can clean it up and look a little easier. So only of the students greater than a 3.0 GPA. So only out of these, what are the chances of not attending grad school? Well, the not attenders are 18. So it'd be 18 out of the total number of greater than 3.0 GPAs, which is 96 plus 18. That's 114. Again, that came from the sum of 96 and 18. So 18 out of 114, put in our calculator. 18 divided by 114. Hit math frac. 3 out of 19. Okay, lastly, this letter D, we have the probability of having less than a 3.0 GPA. So we want the probability of getting somewhere in here, given that they're attending grad school. So only of our grad school attenders, so only of the grad school attenders, We know we already add those, that's 128. So out of the 128 grad school attenders, what are the chances of selecting someone with less than a 3.0 GPA? And that's 32. So 32 out of our 128, which 32 goes into 128 4 times. So that'd be 1/4. You could also put that in the calculator and hit MathFrac. That concludes our podcast on homework 3 in probability.